Hi guys, this video is for my Algebra 2 students. I'm going to be doing lesson 67 today on page 273. Excuse me. The first thing you need to learn is a new vocabulary word, what's called a conjugate. In mathematics, there's a conjugate in English and there's a conjugate in mathematics. Conjugate in mathematics is used whenever you have two numbers added to each other. If I have a plus b, the conjugate is a minus b. You change the sign of one of your terms or the other. Usually we change the sign in between them. A plus b, I change it to a minus b. I could technically change it to negative a plus b. You change one of them. I changed this b from a positive to a negative, or I could have changed the a from a positive to a negative. This second one we typically don't do. We can if we need to. And anytime we multiply a number by its conjugate, we always get the first term squared minus the second term squared. And this is handy for doing problems like we have in lesson 67, where we have a radical, a square root in the denominator, and they don't like it there. It's almost like having a fraction within a fraction. You don't want a fraction within a fraction. You want to get rid of that. So we're going to use this important information. Now I could show you why it always comes out to the first one squared minus the second one squared, but I'm not going to bother with that. By the way, that minus is very important. It will never be plus. Here's an example that is not in your book. This is one I just made up. Here's 3 over 2 plus the square root of 3. We want to get rid of that radical. If we simply multiply both top and bottom by square root of 3 over square root of 3, which is the kind of thing we've done before this, we'll mess up. We'll get 3 square root of 3 in the numerator, but we'll get 2 plus square root of 3 because it's distributive property, and minus square root of 3 times square, or plus, square root of 3 times square root of 3 equals 3. We still have this radical in the denominator. So just multiplying by the square root of 3 doesn't do it. We are going to multiply both top and bottom, numerator and denominator, by the conjugate of 2 plus square root of 3. I'm going to change that plus to a minus. In the numerator, yes, I said it right. I've got distributive property. 3 times 2 gives me 6. 3 times square root of 3 gives me 3 square root of 3, and it's minus because of that. In the denominator, I'm going to go ahead and work it out and show you why this is true. I can tell you right now it's going to be 2 squared, which is 4, minus square root of 3 squared, which is 3. My denominator is going to be 1. Well, let's work it out. Distributive property, 2 times 2 is 4. 2 times negative square root of 3 gives me negative 2 square root of 3. Square root of 3 times positive 2 gives me 2 square root of 3. And then positive square root of 3. And then square root of 3 times square root of 3 gives me 3. And it's positive times a negative, so it gives me minus 3. I have 6 minus 3 square root of 3 in the numerator. This 2 square root of 3 and this negative 2 square root of 3 eliminate, and I have 4 minus 3, which is 1. I told you it was going to be 1. Now we could have avoided this multiplying out if you just remember that it's always the first one squared minus the second one squared. So let's look at the examples they give us in the book. I'm at the middle of page 273. It says 1 over negative 4 plus square root of 3. I can do this conjugate. I can change this to negative 4 minus square root of 3, or I can change it to positive 4 plus square root of 3. I said that would hardly ever happen. I'm going to show you why, because I don't ever like that negative first. I'm going to change this to square root of 3 minus 4. So now my conjugate that I'm going to multiply by is square root of 3 plus 4. Up here, I could have just changed that negative to positive 4 plus square root of 3. I would rather switch the order and then change the middle term. You don't have to do that, though. In the numerator, square root of 3 plus 4. So 1 times square root of 3 plus 4 is just going to give me square root of 3 plus 4 in the numerator. And what did I say? Your denominator is always the first one squared. What is the square root of 3 times the square root of 3? It is 3. Minus, whether this is minus or this is minus or this is plus or this is plus, doesn't matter. As long as you've got the sign changed, that second term will be minus the second number squared. What is 4 squared? It is 16. So you're going to get square root of 3 plus 4 over negative 13. Often the book will change that and they will bring the negative to the top, making everything in the top, in the numerator, negative and leaving the denominator positive. The book in this one did that. They brought the negative up, and they have the negative 4 first. Order doesn't matter as long as you have the signs correct. I would accept this answer right here. You can keep the negative in the denominator. You do not have to bring it up to the numerator. Let's do the next one. Bottom of page 273. It says 3 over 2 square root 3, and I believe it was square root 2, yes it is, plus square root 2. The conjugate of this is 2 square root 3, that doesn't change, and square root 2 over here, but the plus becomes a minus. And in the numerator, on top, same thing. 2 square root of 3 minus square root of 2. Why? Because this over this equals 1. We're multiplying by the number 1. Multiply this out. 3 times 2 square root of 3 gives me 6 square root 3. Square root of 3 times square root of 2 gives me square root of 6. In the denominator, it will be the first one squared. Now I'm going to show it over here. 2 square root 3 times 2 square root 3. Well, that's 2 times 2, which is 4. Square root of 3 times square root of 3, which is 3. I have 12 minus the second one squared. What's the square root of 2 times the square root of 2? It is 2. So I get 6 square root 3 minus the square root of 6 all over 10. Now you have to stop and ask yourself, is anything reducible? The square root of 3 and the square root of 6 we're not looking at. We can think of this as like 6x minus y all over 10. These radicals are just like variables. All right? Can I take anything out of every term? I cannot. If this by chance had a 2 or a 4 or a 6 or 8, and if it had an even number here, I could factor out a 2 and reduce everything by 2, but it doesn't. So that is an irreducible fraction. All right? Is there one more? That is it. I would encourage you, try the practice, if you will, but if you do, you're going to change that to square root of 7 minus 3. In the homework that I gave you, number 6, change it to square root of 5 minus 4. That way you can change the middle sign and the sign between the two numbers, and it won't be as much of a problem. That's all there is. Hope that helps you out. See you guys later. Bye.